Let's take a quick look at correlation versus association. Okay, so here's the deal. Correlation speaks to a linear or straight line, or straight line relationship between well, actually two numerical variables. Okay, so now you know, technically speaking, you can use some categorical variables, but you're doing stuff at that point. So you know, you're making transformations and various things like that. So when you're just plotting things, correlation is a very specific thing. Okay, it's this linear or straight line relation or association between two numerical variables. And we won't see this, or we'll see it in chapter 5. Okay, so until then, use the word association. Okay, because if you use the word correlation, I would say most likely in the first 4 chapters of the book, you're wrong. Now, you know, some things we'll look at would actually have a good correlation, but typically we're talking association. And so, again, the idea is, you know, here's an x variable, here's a y variable. You know, if it looks like this, and I would say, oh yeah, that looks like a straight line relationship. Okay, that has a good correlation. And would have a reasonable, reasonably good correlation coefficient. Okay, so and I'm only introducing this to try to get you to not write things incorrectly. So the correlation coefficient is designated by the letter R, and R is between -1 and 1. Okay, and values near -1 or 1 indicate better correlation. Okay, so that's what we're talking about. So to give you an idea of how correlation and association are different, typically So typically, with two numerical variables, we would like to predict the value of one from the other. Okay, and the better or the stronger, I guess, would be a better way of putting it. So, oops, let me erase that. The stronger the association, the better we can predict. But we'll see that the correlation part doesn't necessarily indicate a stronger association. Okay, so let's look at, let's look at some Desmos stuff here. And so I have, an x1, I have some x values from 0 to 10, so 11 values. And then I have two different sets of y values. So one I called q, and the reason I call it q is the data, when you first plot them, you might think, oh, maybe it's a quadratic relationship. It's not. It's a higher degree than that. But, you know, as you look at the data, you might think that. And then L, you know, those tend to look like a linear relationship. Okay, so there are our data. Let's see if I can make this stronger looking. Yes, I can. Okay, so there are my data. And that is definitely not a straight line. However, using, and this is just some stuff I did to check some things out, but I can, in Desmos, I can fit a straight line to these data very quickly, and that's, oops. Well, I'm not sure. Let me click in there. Let me click in here. Now I can do it. Okay, there we go. So there's a nice straight line, that blue line. And that is the best straight line that fits that data in a regression sort of thing, or a least squares idea. And I can't draw it here, but as you look in that spot with Q is associated with AX plus B, so a straight line. You look at the R and it's 0.81, which is close to 1. I mean, you know, it's not bad. So that's okay. However, I would not use that straight line to try to predict y values from the x values. Actually, I would use x to the 5th over 10,000 because it's a perfect fit. That's the way I happen to make those data. So there is a perfect association, and so you see the correlation of 0.81, which isn't bad, really doesn't help me out though. You know, those data are definitely not well correlated. They are obviously, so we'll get rid of that blue line, they're obviously in a curve, and in particular, they're in a curve x to the 5th over 10,000. And so that is a perfect association. If I look at something like that, I can predict my y values from the x values absolutely perfectly. And so, that is a great association. The correlation, so-so. Okay, so now let's compare that with these data. And let me get rid of that stuff. Okay. And as I look at these data, they actually look not bad as far as a straight line. And if I check L, I'll try to find the best straight line to fit those data. Well, you see, it looks pretty straight. It looks, I think it looks pretty good. However, I will say that, trying to predict the y value, I'll do okay, but I'll probably have some error because those points do not all land specifically on that straight line, but it's not bad for predicting. Now, if you look at L over here, and again, I can't draw. If you look really closely, you can see the tip of my stylus in this box, but the L being predicted by AX plus B, or A1X plus B1. Now, if you look at that correlation coefficient, it's 0.9347. So much better than the 0.81 if you look above up there that I had for the quintic data, the x to the fifth data. So you see, I can't predict as well. However, the correlation is way better. I mean, it's up at 0.93, and that's getting very high. And so you see, correlation, it definitely has something to do with predicting, but it's about predicting along a straight line. And you can have data that are not quite as strongly associated as some other data, but have a better correlation coefficient. And the reason is these data in blue are more in a straight line, and that is what a correlation measures. Okay, so if we go back to both sets of data here, the red data are much stronger associated than the blue data. However, the blue data are better correlated than the red data. Okay, so you see, if what I'm after is to predict, if I'm really after what is the relationship between these two variables, say x1 and q or x1 and L, then I really want to talk association, not correlation. Correlation, if I go on and on about the correlation of the red data, I'm just wrong. Okay, because that's not what I'm interested in. I'm interested in something more general called association, but I'm interested in what that relationship between the two variables is, and you see it's much stronger. I've got a much better predictability on Q than I have on L. Okay, but L is better correlated. So don't use correlation unless you are truly trying to speak to a straight line relationship. You're trying to say, yes, these two variables share a very nice straight line relationship. Then, hey, it's okay to say they're correlated. Or if you want to say, these don't share a straight line relationship whatsoever, they're very uncorrelated. That's okay. But you're going to mess it up most likely. So the thing to do is don't worry about the word correlation in these first 4 chapters. Worry about association. What is the relationship between the two variables I'm looking at? And, that I'm talking about association. I want to know, just exactly how strongly they're related. And that I want to use the word association. So hopefully I've used the word association enough that you will maybe associate it with your work. Okay. But so there we go. We've got correlation versus association in these first 4 chapters. All you really want to talk about is association because we aren't specifically looking at correlation until chapter 5. All righty. So we'll call that done.